and they're reacting, and one of the products is hydrogen gas, H2, Brinkelhoff. Okay, we know it's H2, it's diatomic. Now, it's not the only product because we can't magically get rid of iron and oxygen, but we can assume that this is a single replacement reaction. So iron kicked out hydrogen, and so now it's iron. What is the charge on iron? Let me go back to the problem. Iron 4 reacts with oxygen, FeO2. And now we need to balance the equations. Okay, I need 2 of my oxygens, so I'm going to need 2 sets of the hydrogen gas, or 4 hydrogens and 4 hydrogens, and 1 iron and 1 iron, so I'll make it pretty. And now I'll write my knowns. 45.0 liters of water. So magnitude in unit goes right above the species. And what is the mass? Okay, so we need the mass of hydrogen gas produced. That way I have my pathway. So when I'm looking on my mole island, I'm starting out with liters of water. So archipelago A, because it's the first one. Liters of water. I can't jump on the mole ratio from there. There's T-storms there. I have to go to Mole Island first because that's the only place it's big enough for the mole ratio boat to dock. So liters to moles to the mole ratio so we can convert from one chemical to the other. We land on moles over here, and then we're going to grams because we wanted to find grams at the end. So what's that pathway again? We started off on Liter Island. Then we went to Mole Island. Then we had to use that mole ratio to get to the other mole island. And from that mole island, we had to go to grams. And if I read on my mole island, liter to mole, we use the 22.4 conversion. Mole to mole, we use the mole ratio. And mole to gram, we use the molar mass. So we write down what we know. 45.0 liters of H2O. We're going from liters to moles, so we're using 22.4. At STP, there's 22.4 liters in 1 mole. And if they don't say it, you should always then write up somewhere, assume STP. Okay. So now I have my liters of water. It's being converted into moles of water, so I made it here to that first stop. And now I have my second conversion, so my second bar, and that's mole ratio. Moles of water is on the top, moles of water goes on the bottom. Who am I converting to? I'm converting to hydrogen gas, so moles of H2 is on the top. There are 2 moles of water for every 2 moles of hydrogen. So even though these are the same, you still have to do it because you had to convert those units to hydrogen gas. So if we stopped right here, we'd have moles of hydrogen gas, but we need grams, so we need to go one step further. For every 1 mole of hydrogen gas, this is never anything else. When it's molar mass, it's always the mass per 1 mole. So it's 1 mole of hydrogen gas, and that's 2.02 grams of hydrogen. The moles cancel, and you can simplify here. 2 over 2, if you didn't want to plug that into the calculator, that's fine, simplify that. 45.0 divided by 22. Let's try that again. 45.0 divided by 22.4 times 2.02 gives me 4.05803 and so on, but I only need the first 3. That 0 is important because it's a trailing 0 with a decimal. So 4.0, and that 5 rounds to a 6 grams of H2. And I box that answer.